Welcome to the Building Web3 podcast. I have my good friend, Bo. He is the co-founder at Polymer. Before we get too deep into Polymer, tell us a little bit about your background and how you got into founding Polymer.
Yeah, happy to. And thanks for having me on. I started off working mostly in Web 2. I did work at Uber and a bunch of other smaller startups, mostly in high-performance database systems. I think database systems naturally an interest of mine. I think earlier on in my career, I tried to pick between three areas that I felt were technically deep and interesting. It was compilers, operating systems, and databases. Databases had the most variety in terms of like job opportunities, projects, and startups. There's not too many startups building their own compiler and operating system. So with the database route and switching over to crypto, I spent some time moonlighting in DeFi, but naturally I wanted to work more on the infrastructure. And mostly because I see crypto as just another set of databases with different constraints, Byzantine fault-tolerant constraints, essentially, and other constraints as well, of course.
So talk to us a little bit about what Polymer is for people that are unfamiliar. Let's say they've never heard of Polymer or interoperability. Like, talk to us a little bit about like what's the mission and what you guys are hoping to accomplish.
Yeah, I think the mission started off very broad, but the mission kind of iterated and honed in on a more focused customer segment over time. I think initially we wanted to solve interop broadly. And as time passed, we decided to like hone in our focus on a specific segment of the market, specifically rollups, and even more specifically Ethereum rollups today. So we're essentially trying to connect all Ethereum rollups at very low latency, and also do our best to serve the interests of the builder and try to build around like builder requirements in that rollup domain.
Yeah, let's talk about interoperability because people are a little bit more sophisticated. They're like, "What interoperability? Like, doesn't all the layer 2 specifications it comes with its own bridge?" No, like, talk to us a little bit about like interoperability and like why we need solutions here.
Yeah, so I'm going to speak mostly from the Ethereum rollup market, just so we're like focusing in terms of the discussion. Every rollup has a bridge. There's a native bridge to the rollup. So if you deploy a rollup today, your rollup will also deploy a smart contract bridge. You can use that smart contract bridge to bridge forth back and forth L1 assets. You can also use that bridge to communicate to other rollups, but especially in the case of optimistic rollups, the lag time is quite high. A full round trip could take 14 days. And a lot of people we found, or a lot of builders that we found wanted something much, much faster. Much closer to real time in terms of communications across them. There are a few solutions that are being worked on within each ecosystem of rollups and by other infrastructure players, but there's now just a lot of different competing solutions, and you kind of see the rollup landscape of Ethereum slowly like fragment into like clusters of like natively interoperable rollups that don't and then a bunch of infra companies that will connect across them as well.
Yeah, let's actually real quick because we've interviewed many of these solutions. So things that come to mind would be like Arbitrum Orbit, maybe the super chain. Then you've got like an Omni. People can go back to that episode. Particle. Talk to us a little bit about like some of the current things that are out on the market and how people have addressed this, and then how you guys are kind of taking a different approach to it.
Yeah, so the current solutions, I don't believe Arbitrum has an native interop solution yet.
Interesting. I didn't know that.
Yeah, I'm under the impression that they don't. Don't quote me on this because I don't follow Arb Dev like on a daily basis. But my understanding is that they're working with infra partners on the interoperability side. I think Espresso is one of those partners. Espresso has produced a standard called CIRC for communicating between rollups, especially in a trust minimized way for rollups that will settle together. The superchain has superchain native interop, which is under active development. the Polygon ecosystem, they have, I don't know if they still call it the LXLY bridge or LXLY interop protocol. They might have a different name for it now, but they have something as well. And that one uses zero knowledge proofs. The strategy between ZK and optimistic rollups at a really high level is a little bit different. I think a lot of optimistic rollups and maybe even some ZK rollup ecosystems are trending towards allowing fast path communication with little to no verification, meaning that, okay, let's just let these rollups communicate at like basically intra block or at low latency inter block, so between blocks or within blocks themselves. And then we'll figure this all out at settlement time, meaning we'll do settlement time verification. So this is like lazy verification. And then there's some zero knowledge ecosystems that do pessimistic verification. So in those systems, you will verify a zero knowledge proof that the rollup state transition is executed properly, giving you some route, a state route that you can use to then communicate between via proofs between rollups in that cluster. Both approaches are valid. They're not mutually exclusive either. And this is mostly just for native. I haven't talked about third party yet.
It's quite interesting because ZK is a very interesting solution. We just had the founder of Gelato, and now I guess he would also be the founder of Abundance, and they were talking about like how bearish for I'll just paraphrase how bearish they were on like ZK. He's like, I think it eventually will be the future, but it's just so cost expensive. You got these co-processors, and he didn't think it was necessarily worth it at the moment. But I'm curious, so we can transition the conversation a little bit into your guys' approach and like how you guys are approaching like this different. I know you guys have used IBC, so I'd love to see like how you guys approach this, and then like why go with IBC.
Actually, we currently using a lower level API for IBC. So if I were to say that IBC is a messaging protocol, beneath the messaging protocol, you have IBC primitives. You have the concept of IBC clients, which is a template for verification between chains. You can create these clients, and you could think of them as a light client for connected rollups, but it's just some verification logic. You can find them in other systems. Maybe you could even think of them as like a hyperlane ISM or a layer 0 DVN. But the verification logic is completely on chain. Our strategy there is, after talking with builders, we realized that builders want low latency between rollups. And two, builders are okay trusting the sequencer at low latencies. Because if you want to go fast, and I'm talking about before rollups data is published to their data availability layer, you're stuck trusting the sequencer, meaning that the sequencer controls ordering, so that even if you have like a ZK proof, it doesn't help you with security in that case, because the sequencer can do something called equivocate, meaning they can tell you, hey, I ordered things one way, and then do a little switcheroo by the time they actually publish data to the data availability layer. So with these assumptions, the product that we built is it uses sequencer verification or sequencer pre-confirmations as verification. and additionally, our chain aggregates the block headers of all connected chains, allowing us to expose native proofs to the end application, meaning that we don't deal with messaging. We sell proofs instead, if that makes sense. Meaning that they can prove the existence of a log or prove the existence of a storage key on a counterparty chain.
Got it. And does this play in, because I know you guys have a new proofs API. Is this essentially what you guys are bringing to market?
Yeah, exactly. Yeah, exactly. Sorry.
So talk to us a little bit about like what this proofs API is. So if I think about like historic bridging solutions, it's like you'd have maybe somebody would lock up a certain kinds of assets, then you would mint it on a new chain, or maybe you would destroy the original asset, you would mint it on a new chain. Now talk to us a little bit about how you guys kind of approach and like how this kind of varies, because I want to think about like maybe I'm launching the Jax rollup, and the Jax rollup, I'm like I want to use Polymer, I like those guys. Talk to me a little bit about like how Polymer would work, like how I would integrate Polymer and how that would allow me to talk to other rollups.
Yeah, so the integration UX is a little different, although in terms of like the type of token bridge you can build on top, the type of like intense protocol you can build on top, that's pretty much the same. You can still build the same things cross chain. It's just a different when it comes to cost and integration UX. The integration UX here is you don't have to integrate a smart contract to send a message, meaning that no message sends are required. Instead, you can request for a proof of an event that happened in one of your smart contracts or in many of your smart contracts. So the UX is you create an application, your application emits some events. You can later then prove that your application processed like XYZ events at some scale. And you can either do individual proofs for this, or you can batch the proofs together and prove all of this at once.
Okay, so we've got now the proof API. I can guarantee pretty much that a certain event was emitted from a specific kind of data. Let's maybe for the less technical listeners, let's talk a little bit about like why does somebody even need this? Like why do we need to prove that like Jax DApp emitted some kind of event?
Yeah, so I'll use an example here. I'll use an intent-based bridge as an example. And let's say you take a cross. Right now, what a cross does is you have a bunch of fillers that come in and fill user orders. So users express some like cross-chain order. Fillers fill the order and then wait to be paid back by the protocol. The settlement protocol in a cross today uses UMA. That's their optimistic oracle. The whole process will take anywhere between 1 to 2 hours. Meaning that the solver's inventory is just held up in the system. And I think Nomio did some interesting research recently about, I would say like balance owed to solvers. It averages, I think, in the like tens of millions or 10 million plus at times. And that means that you have limited capital efficiency if your assets are being held up for an hour or an hour to 2 hours. Polymer's goal is to decrease the settlement time for this. So if they were to use Polymer, instead of the filler waiting for the system to optimistically settle their fills and verify that they happen, what they can instead do is they can show proof. They can say that I did a fill, and then I'm going to get a proof of that fill, and then publish that proof on the source chain or wherever I want to get my assets back. And they'll be able to do this between 6 to 10 seconds. And this increases the capital efficiency of the system.
All right, so let me give an analogy for people that are that maybe they haven't heard our other intense episodes. So let's imagine we are all running some kind of like decentralized Uber. So you pick the start location, and then you pick the final destination, and you don't really care like the exact path that car is going to take. You just care that it's going to be super efficient. So what's ended up happening is now we'll bring this into Web3 world. Like I want to take some money that I have on Polygon and actually stake it into Lido. So I might need to swap USDC for Ethereum, then put that into Lido, and then all kinds of things are going to happen there. But I don't care like where it's bridged. I just want them to do. Mm-hmm. Now I submit that intent, and the solvers, even though they did all that, their money's now locked up. So it'd be like if we take it back to the Uber analogy, it's the person that solved and like got us the best kind of route possible. Their money's locked up for 2 hours. Now with Polymer, if I'm understanding correctly, their money would be locked up for what, about like 10 seconds?
Yeah, less than 10 seconds. We're at 6 to 10 seconds currently for proof generation, and also broadcasting of the sequencer preconfs. But we anticipate that in the long term, we can get that number down even lower to as close to block time as possible.
Wow, that's incredible. So, okay. Yeah. So we'll go back to this analogy. So now the money historically we'll say was locked up for about like 2 hours. And now we're getting it back within about like 10 seconds. So in terms of capital efficiency, obviously that's very helpful. Talk to us a little bit about like, are maybe like market makers or solvers, like because they historically had that 2 hours, are they pretty much like, hey, I can't really solve anymore, algorithms because I have my money locked up? Is that essentially like the goal?
Yeah, I think the the end result of that is the filler behavior is like changes. I think in a study that Nomio did, they showed that although it's more profitable to do fills under 15 seconds, that solver behavior was that they wouldn't solve as much at that frequency or that latency because of their capital being held up. So either increases the velocity of the money, meaning that increases the number of fills that solvers will fill at like a sub 10 second, sub 5 seconds latency, because users actually pay more for those types of fills. And also increases their opportunity to do larger fills. I believe that in the cross system, after a certain dollar amount, that the fill mechanism switches over from like a fast fill or like solver provided fill to a slow fill, which is provided by the liquidity in the system itself. So I think with more capital efficiency, you'll see a lot more range in terms of solver activity.
So now we've talked about the solvers, right? Let's talk about who is the primary audience. Like who is the person on like integrating Polymer? Is it the chain itself? Is it the DApp? Is it? I assume it's not the solver. I think they just kind of benefit from that end result.
Yeah, it's the applications. So cross-chain applications. I mean, we're trying to go after the intense market today. There are other cross-chain markets or cross-chain application markets. Although I will say that like cross-chain applications today are somewhat limited. Most of them involve some type of value transfer. A cross-chain native app that's just cross-chain native because they had to scale horizontally doesn't really exist today. I think people talk about it, but that future is not here yet.
And so I guess the pitch to DApp providers is, I guess it's multi-layered, but if we just take the solver example, it's like, hey, if you're an intent-based protocol, you're able to really increase the capital efficiency of your solvers, which should decrease the cost, or, should increase like your ability to provide better pricing. Is that generally like the pitch to dApps?
Yeah, exactly. So it depends on the DApp use case. In the intense case, we would pick more capital efficiency, faster settlement. In other applications case, we can pitch cost efficiency. A lot of app chains or like app rollups have this model where you have a bunch of like spokes in your application, and you have a hub, and that hub may be a chain. So one advantage of using our system is that block space on your hub chain is far cheaper than the spokes, because usually your most active spokes are going to be like Base, Arbitrum, Optimism, and these chains have demand for their block space. Prices will fluctuate. On the app chain itself, they just have an abundance of this. They don't like really have a ton of volume going over that. So with our proof-based system, the cost model changes from having splitting the cost. We have messaging. You split the cost on the spoke and the hub, meaning that you send a message from the spoke to the hub when something happens. And then we shift the costs all to the hub, meaning that there's zero cost on the spokes, and the entire cost is borne on the hub, which makes it very cost effective for these types of applications. So I think our pitch is like pretty straightforward. It's simpler integration UX, cost, and speed.
Yeah, I'm curious because after doing the Gelato episode, yeah, I've got a lot of thoughts, and then we've had obviously the Solana Foundation, and so I feel personally like I'm stuck between these two worlds of being like, one is like block times will like things will just get cheaper on one chain, and we'll have just like one shared state, and another world where it's like, yeah, everyone's just going to have a chain. It's just like rollups as far as the eye can see. Where do you guys tend to think is the general future there?
I mean, there's a reason why we picked rollups.
Yeah.
I mean, TBD on if Solana develops a thriving rollup ecosystem, which I believe they will at some point.
They've got network extensions, which they've talked about. Now they're trying to be like it's like more than rollups. I don't know if that's just marketing that
I think it's marketing. Yeah, it sounds like marketing to me. I'm not a network extension expert by any means, but it sounds a bit like marketing. Yeah, so the reason why we're banking on rollups is quite straightforward. So like I came from Web 2, so that's predominantly my experience. And when I started working with Web3 and learning about consensus and Byzantine fault tolerant database systems or blockchains, I realized that you're basically shooting yourself in the foot and running a race. If I have to do consensus and I have to deploy geographically distribute all the nodes in my blockchain, if I have to pay the overhead of or if I have to pay the overhead of trying to achieve censorship resistance, all these like blockchain properties, you're essentially running handicapped. We realize that with rollups, you get rid of a lot of these handicaps, especially in the fast path. These rollups eventually inherit security from their base layer, but initially they behave more or less like a web server. So the bet is that long term, this like web server like scaling model is going to be adopted by most types of applications. Perhaps like, value transfer or DeFi is center of gravity is around like a few major rollups, major L1s, and then you're going to have this like long tail, like broad spectrum of different types of applications that are more likely to adopt this rollup architecture.
Yeah, I'm quite curious because your guys is, I would say, in terms of the technical episodes we've done, I'd say your guys is in like the top 5% of most technical products. Talk to us a little bit about like how you guys have, built many of these products. Like one, it seems like you guys work to port lower level things from IBC over to Ethereum. Talk to us a little bit about like what the process was in terms of building.
Yeah, so the process of bringing IBC over was quite complicated, which I won't talk as much about since we're focused on Proof API. In terms of the Proof API problem, using sequencer and preconfs is not that straightforward. There's a few, I would say, like bumps in the road. I would say one bump in the road is that for like OP Stack, for example, their sequencer preconfs are signed over the transaction data of the rollup itself. So we've had questions before, like, why can't I just use the sequencer preconf directly on another rollup? And the answer is that you can't. And the reason that you can't is because you have two communicating rollups that sign over their transaction data. If you need to pass the entire transaction payload of one rollup to the other, the write amplification that you end up with will cause both of the rollups, I would say, like data size to spiral uncontrollably, if that makes sense. You're doubling them out every time. You're kind of posting the same stuff back and forth. So you definitely need a chain in the middle to handle this. And then we hit this other bump in the road where if we're processing all this data, our DA bandwidth requirements are quite high, higher than that of ETH DA. We're using EigenDA to kind of handle the amount of data load that we're putting through the system. The other issue is that the connections themselves are somewhat flaky. You're not going to get every single header. You're going to get some of them, and you have to fill in the gaps. In order to fill in the gaps, you have to do these like backwards, like fill-in updates where you associate for each of the gap the header that's in the middle, and you have to like prove the relationship of those to
Sorry, real quick. Why are we not getting all the headers? Is it because we're reducing the like we have this chain in the middle and some things are being parsed out or truncated? Like what is why aren't we getting all the headers?
Yeah, so to get headers from OP Stack, if they run a vanilla deployment, they're I believe the OP node implementation or the sequencer, you can call it the sequencer, that exposes a P2P network endpoint that you can just join. So if you were to join the network P2P network of this sequencer, you will also have some peers that you'll discover as you join. It's just a connectivity issue. Sometimes peers drop off. Sometimes there's like network instability, and you end up with not receiving every header. For more robust networks, so for like Optimism and Base that have better, like more peers or peers with higher liveness or just like better network connectivity. Maybe they're located in more premier data centers, and then you have like the long tail of rollups that you don't know where the deployment is. For those rollups, the connectivity is a lot flakier.
Yeah,
This is
it's
just
quite
basic
interesting.
like networking issues, I think.
Yeah. It's just interesting to think about because I don't think about like roll up networking all that much.
Yeah.
So let's talk a little bit about the Proof API because I know this is the big launch for you guys. So talk to us a little bit about like what's the integration process like? Is there just like kind of like a standard Polymer SDK that I install? Like how does it work?
No, there's no SDK. There's nothing. The reason we did this is because we wanted to focus on building one product and doing it really well. I know I would actually call a lot of interop protocols, and we're going to refer to like Wormhole and perhaps even Layer Zero as full stack solutions. They offer a lot of tooling, a lot of things to like. Sometimes they have like SDKs they can use in the UI. They have a lot of things in their stack for for building applications. Uh, the only thing that we wanted to offer to apps is just a way to efficiently and quickly prove things. That's it, across chain. It's not prove things because like if I say prove things, you're going to think of like Lagrange, you're going to think of these ZK coprocessors, and I think there's some conflict there. So I'm going to talk mostly about cross chain proofs to kind of distinguish what we're doing and what they're doing. Although like there is some overlap, and we are very friendly with some of those orgs. We wanted to build this really simple primitive where you can just request a proof and use that proof anywhere to prove that these events happen in your application. So there's no SDK, there's nothing. It's just a simple API. In the future, we'll even allow developers themselves, they want to run this API in-house because it's not centralized. Like the blockchain itself is decentralized. The API is just like a simpler access interface. You could do the proofs individually, meaning that you could build the proofs manually by querying all the different RPCs of our chain, their chain. It's just kind of like a lot to do. But so we're offering this API to folks. So they just request this proof for some number of logs or events across these different chains, and then just publish that to the chain that they want to verify it on. And that's pretty much the entire integration.
Simple enough.
Yeah.
So tell us a little bit about the like Polymer adoption. Like where are you guys at? Like how many like collaboration partners do you have?
Yeah, so for the Proof API, since the product is a little bit earlier, we're working with a number of launch partners at the moment. So we have 2 to 3 that we're actively working with, and 4 to 5 in the pipeline. The strategy is to like iterate with the early folks to further simplify the UX of using the API before opening up for a broader user base.
Perfect. And if we could go into maybe some of the milestones, like, so you guys are kind of having this, like, I wouldn't call it like a test group, but maybe like a selective group of people that are going to try it out and give you guys some feedback. When can people kind of look forward to for like when everyone like general access GA?
Yeah. General access is probably going to be early next year. So not Q5 this year, unfortunately. So like Q1 or Q2 of next year. Yeah.
Nice. And then finally, we always ask all of our guests for one startup idea. So this could be something that you've seen, like you're like, if I wasn't working on Polymer, I'd definitely be approaching this. We're always looking for areas that like our builders can jump on. Is there any area of the crypto ecosystem, one, that you feel like is either under addressed, or two, you're just like, you know what, I feel like this is going to be so big in 2 to 3 years?
Yeah, I mean, we're at a place where there's a lot of infra. I think there is a gradual and natural shift towards more applications. So at this part of the cycle, I'll probably choose to just work on some type of application on top. In terms of the actual application, I think crypto has this nice property of allowing folks to be able to bootstrap some type of liquidity that makes sense within the context of the product. And this is not just financial liquidity. Like attention liquidity for like information markets, user liquidity for like a dating app, for example. So like one idea for users is you could launch an app chain and have the only goal of the app chain be, we're going to launch a token first on this app chain. We're going to bootstrap dating liquidity for dating apps, meaning that we're going to bootstrap real human dating profiles. And to actually get this done is not as straightforward as it sounds. So like, it has to be Sybil resistant, right? Like people aren't going to pay, like apps aren't going to build on top of this database if there's like a bunch of bots, and they need to know that it's not a bunch of bots. So like, go work with World Chain. like you use their biometrics to at least give you some protection there. And then on top of that, you're going to need privacy because like people don't want their dating profiles to be completely open. And maybe you can go work with someone like Fairblock, who works on encryption, and then there's other modes of encryption as well that are performant. So you can pick and choose like these like different infra protocols to work with, and focus primarily on distribution. So like you bootstrap this community, you give them all tokens, and then you go and approach YC, so Y Combinator, and like all the incubators, and be like, hey, look, guys, if you're building a dating app, please don't go out and bootstrap your own dating liquidity, because the customer acquisition costs are crazy high for dating apps. It's a high failure rate. Why don't you use this existing liquidity that's on chain? I know you don't care about blockchain. These apps don't care about blockchain, right? But if the dating app liquidity is on chain, they might as well plug into this API that's an on chain API to connect with these profiles. And these users kind of have an incentive to use the app if there's like some way they can work in like a token to app relationship as well. So I think that's probably what I would recommend for builders today.
Yeah, it's so funny you bring up the dating app. Initially, I really laughed because I was just like, dating apps, interesting. Because dating apps have this very, they have like essentially an inverse, like they have like a bad market dynamics. So essentially most women, if we look at like hetero dating, is they actually don't want to be on there because most like beautiful people will be like, yeah, I just walk outside and people come to me. You're like, yeah, why would they use a dating app? But it has an inbound of guys. So yeah, it would be interesting if you could have some kind of like payout mechanism where you're like, hey, women are rewarded at like an 80%.
Exactly. You solve the market dynamics with the token, because like you inherently like compensate their like lack of interest in the other side of the market with the token, and then but that brings in like more quality guys. So that's like you solve the bootstrapping problem with some like interesting tokenomics.
Yeah. Hey, this is the best idea we've gotten on the pod, I'll have to say. So finally, where can listeners, one, learn more about Polymer, and two, connect with you online?
Yeah. So we have some docs. We're going to update them very soon. Right now, the docs are focused on messaging, focused on IBC, but we're going to update the docs to focus on our proof API. You can reach us in the future via our website with the docs, or you can just DM me directly. I'm Brobobo _ Bobo on Zeter, and you can also feel free to DM any of our team members that are on the Polymer Twitter. So Polymer Twitter is Polymer_labs, and there's a few of our company accounts on there. You can see them in following.
Awesome. So if people weren't able to completely understand that username, I will put it in the description. You and like Terry from Eclipse have some of the funniest usernames. I love it. All right. Well, until the next episode of Building Web3, let's continue building the future of on-chain.